Question 5 is looking at the trend in ionisation energies as you go down a group. It starts off with a statement. The trend in the first and second ionisation energies of group 2 elements can be linked to the increase in chemical reactivity down the group. Then it gives us a table of data for the first and second ionisation energies of two of the group 2 metals. Then there's two parts of the question. The first part says write an equation including state symbols to represent the second ionisation energy of strontium. So in terms of command words, we're told to write an equation and a bit more information that they want to see the state symbols, so that's important that we do that. And then the command word in the second part of the question is explain. Explain why the first ionisation energy of strontium is less than the first ionisation energy of calcium. Key information, we are looking at the second ionisation energy. That's in bold. It's important that we pick the right one. And we're looking at the trend as we go down a group. Now, as we go down a group, we are adding more shells of electrons. So the outer shell electrons are getting further away from the nucleus, so that's going to be important. And also we need to think about shielding. We are increasing the shielding as we go down the group. Not a lot to talk about in terms of how we structure this, because it's pretty well structured for us. So let's just go straight in and have a go at answering it. So first of all, write an equation for the second ionisation energy of strontium. So the second ionisation energy is going to form an Sr2 plus ion. So if we are making that Sr2 plus ion and releasing an electron, we must have started with an Sr plus ion. Don't forget the state symbols. Ionisation energy is always defined as gaseous ions. And then the second part, explain why the first ionisation energy of strontium is less than the first ionisation energy of calcium. So what we're going to be saying here is strontium has a larger, important to say larger, not just large, because we're comparing it to calcium, atomic radius, as it has more shells than calcium. These increased number of shells mean that there's more shielding. And then the other thing that's happening as we go down the group is there are more protons in the nucleus, so the nuclear charge is greater, which would increase the ionisation energy. So that effect must be overcome by these two effects of atomic radius and shielding. So what I'm going to say here is these two factors, the atomic radius and the shielding, overcome the increased nuclear charge, meaning that the nuclear attraction, important to be clear on the difference between nuclear charge and nuclear attraction. Nuclear charge is the number of protons in the nucleus. The attraction is the attraction of those protons for the outer shell electrons. So these two factors overcome the increased nuclear charge, meaning that the nuclear attraction for the outer electrons in strontium, for the outer electrons in strontium, is lower than calcium, so less energy is needed to overcome it and remove those or that electron. So key things here to remember is we are talking both about atomic radius and shielding. There's 3 marks for this, so there's quite a lot of detail needed. So we've got to mention the atomic radius and the shielding, and then we've got to talk about we've got to link that to the nuclear attraction and the energy needed to overcome that nuclear attraction and therefore remove the electrons.